Good morning, ladies and gentlemen, and to those of you joining us online. I'd like to welcome you to this morning's session organized by Aon Collective. Aon is a Saudi Waqf with a mission of enhancing dialogue and harnessing discussions to advance cooperation and efforts towards sustainable development. Our panel this morning is entitled Understanding and Employing Climate Change Science. It aims to highlight the state of climate change and its impact on the kingdom, in addition to future impacts and adaptation measures and opportunities. Moderating the panel discussion is Aon Collective's co-founder, Princess Masha'ala Sha'lan. Thank you.
Thank you very much, Halia. Well, good morning, everyone. I think the intention behind today's panel discussion, as we'll be hearing from our panelists, is essentially to understand climate dynamics on a regional level, and particularly on the level that matters for building buildings, for ensuring how high and how resilient those structures are. You know, the IPCC just graced us, I joke these days, with a hexagon. But that hexagon is not enough for us to understand the dynamics on the micro scale. And with that, we have a stellar panel of discussants. We have, I always love to start with the PhD candidates because they're the ones who are doing a lot of the heavy lifting these days. Natalia Odnoletkova, who's joining us from KAUST. Natalia has done brilliant work, particularly on understanding the dynamics of historic climate change in the kingdom. We've printed a couple of beautiful illustrations of her work, but we'd love to know about the intricacies of the science behind it. How has the climate changed in the kingdom from 1979 to today? So Natalia, you have the floor.
Thank you very much, Princess Michelle. I would like to start express my gratitude for Aon and for the Kingdom of Saudi Arabia and KAUST for having me here and to be able to speak on behalf of the youth and the students on such panel. It is a great honor, and I'm very excited for the panel today. Can I please go to the
go ahead.
Okay, the first slide. Thank you. So I'm a PhD student, senior PhD student at KAUST. This is the leading graduate school in the region, in Saudi Arabia and also in the MENA region. And my PhD is about the studying of climate change in Saudi Arabia, and we focus on the observed effects, the effects that have already happened in the kingdom. What is a historical fact? But before we start, I would like to give a brief introduction about global historic climate change. As you may be already aware that global temperatures have increased by over 1 degree Celsius since pre-industrial times. By pre-industrial times, I mean around 140 years ago, Industrial Revolution in the late 19th century. For many people may say that it's not a big deal, just 1 degree Celsius in such a long period of time, because for our perception of temperature or outdoor conditions, the change in 1 degree may seem almost nothing, right? Today it's 1 degree more than yesterday, like not a big deal, right? But I would like to emphasize that the effects that are caused by this 1 degree global temperature change are very drastic, and particularly in this region, in Saudi Arabia and surrounding countries, GCC states. The kingdom is experiencing one of the fastest warming rates on the planet. And since 1979, the temperature across the territory of Saudi Arabia has increased by 2.1 degrees Celsius. And this is 3 times the change in global average temperature over the same period of time. And this is 50% more than over the Northern Hemisphere land. This is very, very impressive and drastic change. What is important to emphasize is that summers, which are already very hot in the kingdom, are getting warmer faster than winters. And on the right panel, you can see the difference between summer temperature change and on the left, you can see the change over the whole period of across the whole year over Saudi Arabia. So summer temperature have increased by around 2.5 degrees Celsius compared with 2.1 degrees over the whole year. The next slide. Another interesting observation is that nights are warming faster than days. For example, in Riyadh, the change in summer minimum temperatures, which represent nights, is about 4 degrees Celsius since 1979 in the past 4 decades. This is almost a 1 degree per decade. And this is happening in the context of just 1 degree global planetary change since late 19th century. Imagine what it would look like if we head toward 2 degrees or even 3 degrees warmer planet. What will be the effects in the Kingdom of Saudi Arabia if we experience such drastic changes under 1 degree Celsius global warming? And on the left panel, you can see the distribution of nighttime temperatures in Riyadh. The black line represents 1979-1999 distribution, so the past 20 years in the previous century. And the red shaded areas represent abnormally hot and warm nights, respectively, on the left and right. And the same distribution in red is for this century, since 2000-2019. And you can see how it has shifted toward the right. And now almost every 5th night is considered as abnormally hot compared with the baseline of 1979-1999. So it means that abnormal heat extreme conditions are becoming a new norm nowadays. The next slide. But climate change and its impacts, it's not only about the change in temperature. For people, the perception of heat or thermal comfort depends on the combined effects of both temperature and humidity. And the parameter that explains this thermal comfort is heat index, or the feels-like temperature. Along with temperature, humidity has also increased in this region, namely in the coastal areas such as Jeddah and Dammam and other GCC countries which are located on the Gulf, what has led to a drastic increase in the heat index, what you can see on the right. For example, in Dammam, the change in summer heat index is about 4 degrees Celsius since the late 70s. And this is 2 times the change in temperature over the same period of time. Another interesting analytics is the change of days with dangerous conditions. These are days when daily high of heat index is between 41 and 54 degrees Celsius, and people can experience heat strokes if they stay outside for a prolonged period of time. So these conditions are dangerous for human health. And as you can see, these days are drastically increasing in the coastal cities such as Dammam and Jeddah, but also in Riyadh. This city has seen almost no dangerous days historically, but nowadays there isn't a single year which has no dangerous days. And next slide. And another way to show how the climate affects us is to illustrate the change in the days above 100 degrees Fahrenheit, which is another very interesting analytical tool to describe the effects of climate change. For example, you can see here the key regions and the key cities in Saudi Arabia, which represents key regions. Let's say Mecca, for example. In the late 70s, there was approximately 150 days per year where the temperature was above 100 Fahrenheit or 38 degrees Celsius. But nowadays, it is 200. So plus 50 days in the past 40 years when you have abnormally hot conditions. Next slide, please. So before I give you a quick introduction about different parameters that we have analyzed, but here I would like to present a work that has done by ION using the data that we have analyzed You can see the key cities in the Saudi Arabia and GCC states. And these graphs summarize the change in key weather and temperature related parameters on one graph. For example, precipitation, the number of dangerous days, temperature, and heat index. So if you're interested, we have a distribution of these graphs. So feel free to check them out. And if you have any questions, I would be very happy to answer them after the session.
Thank you, Natalia. Thank you very much. So now we're moving on to Professor Hoteit. We've heard about historic climate change to date. Now we'd love to hear a bit more around what's been modeled in terms of the Arabian Red Sea or the virtual Red Sea, and also beyond that, the virtual Arabian Peninsula, and how can we use that as a way of predicting current weather, but further down the road, climate on a regional scale. So Professor Hoteit, you have the floor.
Thank you very much. Next slide, please. Okay, so what I'm going to talk today a little bit is more about what we're developing to as tools, modeling tools to support the kingdom developments in terms of providing information about the weather now, but also about to provide information about the long-term climate conditions and hopefully what's going to happen in the future. I put all the work we're been doing, we are doing under the umbrella of the Virtual Red Sea Initiative. It's an initiative we started at KAUST 6 years ago. It's still going on, and it is exactly about developing these tools so that can be used in the kingdom. We started with the Red Sea, and now we are expanding for the whole Arabian Peninsula. And actually, I think we made a very good investment in KAUST 6 years ago, because 3 years later, 2 years later, the mega projects along the Red Sea were announced and started to develop now, and the information and tools that I will be presenting today are being used extensively in many of these projects. So next slide, please. So this is a virtual Red Sea, and we split it into three basically components. I would say we were interested in one modeling system, but can address the different time scales of the weather and the climate problem in the Red Sea region. So short-term scales, systems, sub-seasonal to seasonal forecasting systems, and also to look at the interannual and decadal, future decadal variability. Next slide, please. And so this is the machinery we developed. If you push please a button, you will have, these are all 3D models of ocean, atmosphere, waves, ecology, ecosystem, and all the transports that come with it. And they are all driven by the available data, whether it's satellite data or in situ data for our region, all running on our super computing facility in KAUST. And if you move, please, we use this machinery, for instance. Next slide, please. This is an example of why we advise that when we study a region, we need to use the regional products that are generated by models tuned to over the region over the studied region, and using the data in the studied region. I give you an example difference between the European Center medium weather forecast climatology that is available at 75 km and our own product. We generated regional climatology, 40 years of ocean, atmosphere, waves, conditions. This is the wind I'm showing here. And you will see that not only the resolution here, you will see the clear impact of the resolution of the region. If you look at the winds and you are interested in investing in energy, wind energy in NEOM, let's say, and you don't resolve these strong winds over the Aqaba and the Suez canals, then you will miss where the wind energy power is. So it's very important to have regional products when we do a climatology study about historic study about what happened. And this is a clear example why these such products are needed at the regional scale. Next slide, please. So here I want to give you an example of how we use this machinery actually to study the climate of the Red Sea. And the Red Sea is a region basin where we don't have many observations. Not, before KAUST, we have very few cruises that explore the Red Sea. And these are the 6 cruises we found in the last 30, 40 years in the Red Sea cruise. So what we're looking at here is the cross section across the main axis of the Red Sea from north to south, cross section in depth of temperature. So you see a high temperature at the surface, or lower temperature in depth. And if I remember correctly, properly, I don't see very well from here, but we have a cruise in 82. No, if you come back, please. We have a cruise in 82, in 83, then 90 something, then 95, 97. Yeah, 97. And so these are the cruises. And what you see, for instance, in 83, there is a cold water in the northern Red Sea that formed in depth. Okay, that wasn't in 82. And then a few years later, we see it in the middle of the Red Sea. It cooled down a little bit, but we don't see what happened in the north. In 95, we see a huge amount of cold water in depth at 1,000 meters, even deeper, in the whole Red Sea. A few years later, it started to warm up, and then in the 2000, it disappeared. And so we wanted to use this machinery we developed to understand where is this cold water down in the Red Sea came from. Now, the Red Sea is unique because temperature, what we know about the Red Sea, and when we measure down, the temperature is around 20 degrees at 1,000 meters, which is unique. Usually it should be in the handful of degrees. So we used we first checked if our modeling machinery can reproduce such variability that we see at decadal scales. Please, if you move for the next. And this is what we're seeing is model data on left, models on the right. And you see that this cold water in 83, it's not exactly reproduced, but it was reproduced by the model. And once we are sure that the model can reproduce what we're seeing in the data, we can use the model to interpolate what happened between these cruises. And if you move to the next slide, I'll say it quickly. It's what we found out is that this water was found on the surface of the Red Sea. There is some cold air events that are related to the North Atlantic Oscillation every few years, cold weather events that form when the water becomes cold on top, it becomes heavy, and the water down is very warm, it becomes heavier. So it's like taking a rock, dropping it in the Red Sea, and it goes all the way down, water mass formation, deep water mass formation, and it starts moving on the bottom of the Red Sea. And actually it starts mixing the whole column in the Red Sea, and mixing is good. It brings nutrients to the top, so it improves the productivity of the Red Sea. The major 2 water events that happened are related, interestingly, they happened in 82, 83, and 92. They are related to the volcanoes El Chichon and Punatubo, were far away volcanoes that made the weather, created cold anomalies over the Eastern Mediterranean, Northern Red Sea. And this is what made the weather quite cooler than usual, the water temperature quite cooler than usual. And you see this, in the first figure, this blue lines is showing, this happened during these events, and they changed the whole circulation dynamics of the Red Sea. It's happened again, 82, 93. We didn't see it since then. Maybe last year there was something. We don't have data yet about it. And it's very important to know about these events. And usually these events are not resolved by these global climate models because they cannot resolve the Red Sea circulations. So it's very important to know what's happening in the region and understand its dynamics before we start going to long-term projections. I will show you an example if you move on. I think there's a movie now. This is a movie prepared from the best finding we found scientifically from this machinery. There should be some voice in there. I cannot hear it. No?
You're muted, perhaps.
Okay. So basically,
unmute yourself.
okay, too bad if we cannot hear it because
We'll
it
be
seems-
able to hear it.
Okay.
If you could play it again, please.
No.
No.
Okay, so basically what's going on is this is general information about the Red Sea, but what we found out, like seasonally, there are in short-term circulation in the Red Sea. It's mainly eddies, sub-mesoscale, what we call scientifically. So these are just eddies forming everywhere, vortices. It's like taking the spoon and spin it off. You will see it soon. This is what I'm talking about, and that's how it looks. And again, these global products do not resolve these scales, and we see them very well in satellite data. And these are very important for the productivity of the Red Sea. They bring nutrients up, they bring nutrients down, and the main transport phenomenon in the Red Sea is related to these eddies. In real time, this is how it looks like: temperature, salinity, and chlorophyll, and you see clearly the interactions between these quantities. So this is on the daily scale. If you want, now on the subseasonal scale, the system is driven by the Indian monsoon system from outside, not inside. And so the Indian monsoon system in the winter push water inside, bring nutrients to this oligotrophic system, and fuels the productivity of the Red Sea. So there is this overturning cells that turns from south to north. In the summer, because the Indian monsoon system stops in the south, the water starts turning completely in the other side, and the productivity of the Red Sea changes completely. And this is very important if you want to study the climate of the Red Sea, because if the Indian monsoon system will change, the circulation inside the Red Sea, seasonal one, will completely change, and it will have big impact on the system. We can move on from this movie.
You can definitely share the link online. So
yeah, sure. Now this is an example of what we can do with these data sets. We have 40 years of data set regional. We looked at very similar information that Natalia just presented in terms of max number of days of extreme discomfort feeling over the kingdom. Now, actually, our results are not very different from what has been presented, but if you look more carefully about the last 2 decades and the 2 decades earlier, the situation is not that bad in many of the regions over Saudi Arabia. I'm talking in extreme temperatures, in extreme discomfort index in here. Like over Riyadh in the last 2 decades, the number of extremes are not that bad. Okay, it was, if you look at the 40 years as one trend, yes, there is a large trend. But if you look, you split it into 2 decades, the situation is not that bad. In our group, we call it this low-hanging fruit, because once we have these 40 years of data, regionally tuned, using the data locally, we can use it for solar energy, wind energy, extremes. We can do many things, studies impact, and usual studies for the government. Next slide, please. I couldn't but show this a bit provocative, I would say, results that we published, 2 studies. The first slide is the first study actually in 2017, when we looked at the temperatures, sea surface temperature in the Red Sea. We wanted to see how is the sea surface temperature is trends in the Red Sea. We looked at the extreme sea surface temperature, and we looked at the trends, and we see clearly an important increase in the sea surface temperature over the Red Sea. This was in 2017. And we, in this study, it starts, if you look at the data, they start from 85. This is the period where we have satellite data. Okay, so we use satellite data to look at the trends in the sea surface temperature. And we clearly see this very concerning increase in the temperature. An increase in temperature is very important in the Red Sea. We have corals in there, and as you know, increased temperature will cause coral bleaching. Now, the interesting part is that 2 years later, the Red Sea is unique in the sense that it has been always a shipping route trading shipping route. So there are data, historical data, long-term from these ships that collects data along the Red Sea axis. So we went back and used all this data back to 1870. And if you look at the trends from the satellite data in the last 2 decades, 2.5 decades, and this data set from the ships that are not related to the satellite, in the last 2 decades, that the trends are very similar and disturbing. But if you look closely and you go back all the way back, you will see this oscillation trend. So if you move to the next slide, you see this oscillation up and down, up and down. There is a 70-year cycle in there. And you look at how the Red Sea is behaving. There is cold period of cold weather, cold water, ocean weather, then warm, then cold, then warm. And then if you move to the next slide, we correlated this very, very well, 95% with the multi-decadal Atlantic oscillation. It's a weather phenomena in the Atlantic. 70-year oscillation is the same oscillation we see in the Red Sea. And to make people believe us more, there is a study from Germany. In 2000, they took an isotope of corals. Corals is a proxy of temperature. They show you how the temperature evolves. And they reported a 70-year cycle in the coral isotope in the Red Sea. And they said they expected this to come from changes in temperature. It's the same 70-year cycle we see in independent data from the sea surface temperature. We see it in the coral, and it's related to this 70-year oscillation. So when you look at the long-term trend, the short-term trend from satellite data is very concerning. The long-term trend is much less concerning. Instead of 8 degrees in the last 3 decades, the long-term trends over 100 years and so is around 0.4, which is much less than we usually, when we originally thought. And this calls for the people to be more careful about presenting information. There is the era of the satellite data where we have a lot of data. There is the era before the satellite data. And very often when we use climatology data, just the presence, the availability of all this data in the last decades can create trends. So we have to be more careful in how we use these data sets. Next slide, please. Now we use this data also to support many project, government, industry in the kingdom, from NEOM, from Red Sea Project, Aramco, Cake, So we study storm surges, the trend in the storm surges, trend in the sea level. We support the management and the development, design, new airports. We have the 40 years information that designed for the region. An example also, next slide, please. Quickly is, you probably heard about this oil tanker that is stuck in the Yemeni border and made the headlines also recently. And there are around 1 million barrels of oil in there, and it's been there for several years stuck. It cannot be moved, and it is at risk of leaking this oil. So we supported the government a few months back in conducting scenarios or where this oil could move if anything happens, and we can see this in the next slide. And in the summer and winter this is just an example I'm showing you. Next slide, please. Okay, so these are over 20 years where the oil could move in the summer and the winter. And in the summer, it follows what we know about the circulation in the Red Sea. It should move southward, mainly towards the Yemeni coast. In the winter, 99% it will remain far from some Saudi borders, except in 2010, where the wind conditions were peculiar and pushed, they were westward and pushed the oil westward, and it was carried by the northern current we know about. So in 2010, there is some risk of Saudi being affected by the current. But this is an example how this information could be used. So next slide, I'm almost done. So this system, we now developed the first operational, real-time operational system for the Red Sea and the Arabian Gulf, supported by Saudi Aramco. It's now, if there is an oil spill in the Red Sea or in the Gulf, we can go real-time online, few minutes, put the information about the spill, and the forecast will come right 3-4 minutes on the screen. The query will come to KAUST on the supercomputing. The forecast will be done, and it will be streamed real-time online. These are the first two operational systems, ocean, atmosphere, waves, transport, that are real-time for the kingdom. And I put this as under the umbrella of the first component of the virtual Red Sea. And in the next slide, actually, we have signed an MOU with the Ministry of Environment 2 weeks ago between our president and the CEO of the National Center of Meteorology to start the National Climate Change Center. So the Ministry of Environment is going to support. We just sent yesterday the budget, and inshallah it will start very soon. The National Climate Change Center at KAUST, supported by the Ministry of Environment through the National Center of Meteorology, to develop and build the machinery and the information and the know-how on predicting on the seasonal scale, but also the climate change, climate projections on the scales that resolve properly, I would say, the dynamics of the Arabian Peninsula. We talk about rainfall over the projection of rainfall over the Arabian Peninsula, but when you look at the climate models, global climate models, information that are being used, they do not resolve the convective scales, the very small scales nature of the rainfall over Saudi Arabia. These are convective scales. They are not resolved by these global models. So we cannot use these products to claim that there will be less rain or more rain. Actually, when we analyze what happened in the last 40 years in terms of rain, the situation is not that bad in Saudi Arabia. Actually, it's even positive in some parts. So we need more improved information for our region before we started using or claiming that this information could be used to, this is where we want to build dams, or this is what we should be doing. This is where the water will be. And hopefully the center will provide the know-how, the information, and there will be dedicated supercomputing for this center just to do this in a much improved way. And I think, with these resources that we will have through this center and will be announced very soon, I'm hoping that in the next slide, this will get us to where I'm hoping that we'll get there. We're not that far actually. A system, a digital twin of the Arabian Peninsula, where we can address problems from the weather or provide information about the current information about the weather, all the way to the long-term climate for our Arabian Peninsula region. And I think that's it.
Thank you very much.
Thank you.
Thank you. Well, we're all quite eager to get to that future as soon as possible. So good luck with that, Professor. Next, we have Professor Rod Wing, who's joining us remotely. He's the director of the Center for Desert Agriculture at KAUST. Essentially, Professor, we'd love it if you can touch on two main components. The first is in terms of the changes in agricultural practices that spur adaptation for a changing climate, as well as the bit of an insight on the MIWA genomics project that you're conducting. So we're seeing the name of MIWA come up more frequently these days. So MIWA, for those who don't know, is the Ministry of Environment, Water and Agriculture, and they're the ones that are mandated to look at the sort of the dynamics of climate change. So Professor Rod, you have the floor.
Okay, thank you very much. Can you hear me okay? Everything's good?
Perfectly.
Okay, good. First, I want to thank the organizers for allowing me to present today, and I wish I could be there with you all. First slide, please. I have just a few slides today, but I have many words. So two facts is that the population right now of the world is about 7.8 billion. And by 2050, we're going to be at about 10 billion. Another statement I normally say about Saudi Arabia is that it's hotter than hell and there's no water, or not very much water to grow crops. So the question that we raise to ourselves is, how do we feed our world without destroying our planet? How do we feed our world without using up all of our resources? That's a huge, huge task, and this is one that has been it's a challenge that us in agriculture have to deal with every day. So we have two at the Center for Desert Agriculture. We're working on many avenues towards helping to solve this problem, two of which I'd like to briefly touch on today. The first is with respect to plants, crop plants, and their wild relatives. One thing that we are working on is we're trying to capture and understand natural genetic diversity. There's a tremendous amount of genetic diversity that is in the world with respect to crops and their wild relatives. And the crops that we eat today have been domesticated. They've gone through what's called a domestication bottleneck. So they don't have within their genetics the ability to adapt rapidly to climate change and environmental change. So, however, there is genetic diversity that exists in many crop plants, land races, and the wild relatives. Then these have adapted over very thousands of years to millions of years. And so what we're trying to do then is again understand this genetic diversity and capture it and use it to improve crop plants. So next slide. One of the species that a genus that I work on is Oryza. Oryza has 27 species. It includes Asian rice and African rice. Asian rice feeds approximately half the world population as its primary calorie source. But it has, again, due to the domestication bottleneck, it doesn't have the genetic diversity needed to rapidly adapt to changes in our environment. So a question that we have is, can we actually grow crops with salt water? There's a lot of salt water on the planet. Can we do that? So it turns out that there is a wild relative of rice called Oryza corctata. This is a species that can grow in brackish water, and it has a range, a biological range from Myanmar to Pakistan. And so what we are trying to do now is domesticate Oryza corctata. It actually is grown in the marshes or wild. It's grown in the wild in marshes, again, from Myanmar to Pakistan. In Bangladesh, it is harvested in the winter as a sweet winter rice called Uridan. So we know so much about the process of how rice was domesticated in Asia and in Africa, the genes involved in that. So what we are trying to do is take this Oryza corctata plant, which already knows how to grow in salt water, and convert it to a plant that can produce maybe 3 to 10 tons per hectare on coastlines in brackish water. One example of a gene that we would try to change through gene editing would be shattering. When a wild species, when a cereal plant will mature, when the seed is mature, you shake the panicles and the rice falls off. That's called shattering. So one of the early traits that was identified in rice cultivation 10,000 years ago was naturally occurring mutations that no longer shatter. So the rice seed stays on the flower, making it much easier to harvest. In Oryza corctata, that would be a target gene that we would try to edit so it no longer shatters. So we make it so it doesn't shatter. change its panicle architecture so it produces more seed. And this would be using gene editing or by actually crossing cultivated rice into Oryza cortata, which is a bit more difficult, but we have many mechanisms to try to do these modifications, and we have to do it now. So at the Center for Desert Agriculture, we have a focus on fonio millet, which is already a domesticated crop in Africa, very heat tolerant. However, it needs to be improved. It hasn't been gone through a serious amount of breeding. And we're also working with halophytes. Halophytes are plants that can grow in pure salt water for developing oil crops, for example. Okay, another area that we're focusing on, and I think I'm going to have to skip to the last slide. I apologize about that, if you don't mind. Last slide, I didn't have the order proper. Again, very hot, no water. How do you sustainably grow crops in an environment like that? So over 90% of the food eaten in Saudi Arabia is imported. So at the grocery store at KAUST, you can buy blueberries from Ecuador, from Chile. They imagine the carbon footprint of getting that product all the way from like 8,000 nautical miles to our grocery store and eventually to our dinner table. So what we are promoting right now is we're trying to work with MIWA, the Ministry of the Environment, Water, and Agriculture, to promote what we call a paradigm shift in sustainable agriculture in Saudi Arabia. And the idea here is that we develop large-scale controlled environmental agriculture complexes, greenhouses, where Saudis will produce their high-value crops in a greenhouse environment, vegetables, fruit, and then with a combination of very precise agronomic practices for sustainable agriculture, produce cereals, staples within the country, and also import the staples. But really, the idea is to try to invert that importation shift from, instead of 90% of importation into Saudi Arabia, 90% of the food is actually grown in Saudi Arabia. So this is a big push that we're trying to do now. And the Center for Desert Agriculture has a company called, a company derived from the Center of Desert Agriculture called Red Sea Farms, who has developed some new technologies in this area. And also there are other means of helping to do sustainable agriculture as well, using microbiomes. And this is also being done in the Center for Desert Agriculture. Okay, so the next thing I wanted to talk about was even a broader picture. So maybe we can go back 2 slides. Apologize about that. So in addition to agriculture, we also are interested in essentially the plants in the environment. And the idea here is we're working with the Ministry of the Environment, Water, and Agriculture, specifically the National Center for Vegetation Cover and Combating Desertification, led by Khalid Abdul Qadir. And the idea here is to essentially, we call this the KSA, Kingdom of Saudi Arabia, Native Genome Project. And the goal here is to sequence all aquatic and terrestrial life forms that are native to the Kingdom of Saudi Arabia by 2030. And the goal here is to develop essentially a digital catalog of the aquatic and terrestrial life forms to promote conservation and biodiversity in the country, environmental monitoring and protection by having a digital record of critical species that grow in this country. we can do what's called population genetics. We can sample these species from all over the country and say, okay, is a forest expanding, contracting? What are the problems? And doing this at a genome scale. And if we could combine this information with information that had been discussed today in the panel on the climate, on the water, and the increases in temperature, we might be able to come up with a solution to help preserve and conserve the biodiversity that exists in this country. The other piece here is environmental monitoring and protection, and then evolutionary analyses. So there's a few pictures here on this slide. One is the Ajwa date palm. The other onto the right. On the left is Hasawe rice. They do grow rice in Saudi Arabia in the eastern province of Al Asa, and falcons. Falcons are a very important cultural bird in this country, and we've actually developed high quality genomes for all of these species. Next slide. So as part of the Native Genome Project, which started in July of this year, again, we have a collaboration with MIWA, and we've gone on several collection trips throughout the southern part of the country. And some of the photographs you see here is moringa, which is on the right. This is a native species to the kingdom, and it has a number of uses, medicinal uses. In the center is Ziziphus spina Christi, the crown of Christ, and this is also a very drought tolerant, heat tolerant species. It's grown in this country, this is you can develop get kind of very small apples from this that can be used as food and fiber for the country. So anyway, we've started this process now, and we're excited about it. And this kind of leads directly into this the Saudi Green Initiative to plant billions of trees across the country. And we think that this project will allow us to advise on that, to work with planting sustainable plants that are tolerant to this environment, and work along those lines as part of the center. And much of this work that I've been talking about today can not only be applied to Saudi Arabia, it can also be applied across MENA and across the world. So with that, I'll end my presentation as well, and welcome any questions. Thank you.
Thank you very much, Professor Rod. I think that equally reflects on the importance of the role of the Middle East Green Initiative as well, where a lot of the lessons that are learned within the kingdom could sort of have the positive spillover effects within our region. So thank you for that.
Thank you.
Maybe I'll start with my questions with Natalia, since the aim of our session is essentially around understanding and employing climate change science. I know you've done a lot of work on the employment part, but did not really get the chance to talk about the implications for cooling and whatnot, and on some of the work that we've done together. So could you perhaps reflect a bit on why there's a need to understand historic climate change, and then once understood, how could that be translated and reflected into future projections, but with it, the ability to inform the policymaker on what needs to be done to counter potential pipeline of issues. So.
Thank you, Prince Michelle. I would like to start with the fact that, first of all, how can we look into the future if we don't know what is the state we are today, or what we have already observed today? That's why understanding of historic changes is very important.
Also quantifying it, because we don't understand it very well. I think sometimes people confuse weather with climate, and our understanding of what that climate is, we tend to not calculate it properly.
I completely agree with you. our perception of weather, as I say, today is like 1 degree more or less. It's very different from the climate. Weather is very variable, but climate is something about more long term. And this is great that we have all the means of global advancement in terms of technologies that we can study historic changes back since late 70s, or even with the advancement of technologies, we can look even to the past over the region. And
can I push a bit further on that? Because some might question when they look at these data and these circles, again, because of the lack of understanding of climate, is how accurate are those numbers, the numbers that you've used for your study? What are the sources? Are they actual measurements? Can you speak a bit more on that?
Sure. So in our research with ION, we use data from year 5. This is the latest reanalysis of global climate produced by European Commission, ECMWF. I think it's the same source as Professor Ibrahim Hoteit was speaking about. So this reanalysis, what does it mean? It combines the best models of the climate with the observations, and it produces the output in a form of very precise and accurate data set on an hourly basis with a high resolution. And in fact, this high resolution data set which we used is about 0.25 degrees latitude longitude, which is like a breakthrough in terms of scientific advancement. We received it only in 2018, a couple of years ago. Before that, the study of climate change was a little bit constrained in the region because we have a lack of access to the weather stations. And with this data set, we could have seen the broad picture and in very details. So this is what I would like to reflect on that. And the second is that I would like to emphasize that a part of our studies, we compared this data set with the weather station observation. And of course, it is expected that they are similar because this data set is using weather station data, but find that the correlation is so close. So this data set can be relied to a great extent to explain what has already happened with a high degree of confidence.
And that perhaps we'll get back to the cooling maybe, but I'd love to get Professor Hoteit's input on this. Is a bit more of the spirit with which you've created the virtual Red Sea, correct? Is to understand what our dynamics are like today before delving into what these dynamics would look like tomorrow.
You know, we look at the historical period because this is a period where we have data, and it gives us confidence in what we do. You know, the climate projections, they are based only on models that we hope that we reach the level where we can run them for a long time without being constrained with the data and give us reliable information. It's very important to use the historical periods. This is where we have data, especially the period where we have satellite data, because we have spatial coverage of what's going on. You know, one of the main issues in studying climate in Saudi Arabia and in the Arabian Peninsula, they are not long-term data sets and decaded data sets. There are few in the last couple of decades. Proxy data from corals or from sediments become very, very important there to tell us what happened in the past. And with knowing what's happening in the past, understanding, you know, we did it not only to look at the trends, we mainly did it, you know, when we started looking at this to understand how the system functions, how it reacts to the global climate. And I think this is very important before jumping and start doing the projections, because we need to understand, do these projections make sense? Do they fit with what we know? And if there is a change, how it's happening dynamically, and are these models are doing the right things? We don't have data, so physics become our main information in there. And to understand what's going on, we need to understand what's happening before. So, you know, having this period of where we have data, it provides us a confidence on the trends we have now, but also very important for us to be able to say, not with full confidence, but give us more confidence in what we're projecting in the future and what we need, how we do it. You know, we know, like for instance, rainfall. Again, all these projections about rainfall over our region, I wouldn't use it. You know, and we need to understand what happened. What is the variability of the weather we are of the phenomenon we are interested in? Then we go and we tailor our projection machinery to what we understood in the past. So it's very important.
Yeah, and maybe reflect a bit on the age of the Red Sea compared to all of the other bigger bodies. You know, our oceans. The Red Sea is relatively young, so
it is young, it is unique, and it is very narrow.
Narrow and deep.
And narrow and deep, and it's only open to the global oceans through a very narrow strait. All these global models do not resolve this strait. So when we talk even about temperature projection and extremes, if we don't know what's happening in the Red Sea, and also especially rainfall, because a lot of the moisture is coming from the Red Sea, you don't understand what's happening in the Red Sea and the Gulf. I wouldn't say, you know, we should be very careful on how we're using these climate products that are being available now.
Absolutely, absolutely. Professor Rod, I know this is not your area of expertise, but I don't know if you had any reflections on the discussion.
Well, I definitely, you know, think we need to understand the Red Sea. This is an important natural. I consider it almost like kind of a national park in a sense for the region, for MENA, and you know, we need to protect it, and we need to understand its life forms, and be able to monitor it. And but I think there's so much unknown, and I've been involved in some discussions on climate models, and the climate models have been about the Arabian Peninsula, and then I've asked a question, well, is the Red Sea in the model? And the answer was no, and I was surprised at that. And I think it's not that easy to link the two together, but you can't really, you know, do predictions unless you put everything into the equation. And it was very interesting to hear today about this cycle, this 70-year cycle. I didn't know about this, so that's pretty amazing. So maybe it's not as bad as people are predicting it, because right now we're in a 70-year cycle of increased temperature, but maybe it's going to drop down again. I don't know. That's how I
actually.
Yeah, go ahead.
Actually, indeed. So we're projecting that in the next decade, next 10 years, temperature will start going down in the Red Sea. Now we're not that far from that. We are at the peak of the bad temperatures now. It will go down, and then in the next 40 years, it will go worse. You know, there is still a trend, not as bad as before, but you know, we should not be surprised if the temperature in the next decade start cooling off.
Okay.
It's important to understand it, because attribution to these oscillations versus saying that there's no change is equally important to understand the dynamics.
Exactly. The interesting part also, we see it in the winds in the north. The winds are like 20% weaker now, so it's important for energy. We see it in the waves as well, and we expect these to pick up again in the next decade or so.
Yeah, especially when we're having
NEOM
and green hydrogen and all these ambitions. Absolutely.
Exactly.
Then what kind of implications would then, if we're essentially saying that the predictions or our understanding of how we could predict within our region, within extreme details, is not there yet. We're getting there, but it's not there yet. In terms of the policy implications, Natalia, because you've done some work on cooling, and so if we're thinking about risk in terms of fat tails, you're essentially hedging against these fat tails. You might not be accurate, but maybe there are some areas where you're better off overshooting or overprotecting versus not doing anything. So how do you approach those types of policy recommendations? And I know you're at the beginning of your academic life, but I think it's very important to note what those reflections are this early on, and then track them down the line.
Thank you. Although academia can be a little bit far from policymaker making, but I would like to emphasize that we have to treat this thing very seriously, because now we live in the era of abundance of electricity, and energy that is provided to us by Saudi Arabia is blessed with resources. But we have to also plan into the future. Currently, we can afford energy-intensive cooling. Just like brief information, in KAUST, our houses consume around like several thousand kilowatt hours per month. And when I saw these statistics, I was shocked because in Russia, of course, we don't have AC and heating is provided by district heating by gas. But if you don't take into account cooling and heating, I was consuming around 100 kilowatt hours per month. And in Saudi, it is in the form of 1,000 or several thousands if you live in a villa. This is just something people don't understand because it's just a figure, right? But what is behind it? It's a big machine that consumes power at a massive scale. And in the future, we don't know what is the energy mix and how affordable it would be to run the same lifestyle. And we have to pay significant attention on the provision of cooling to the population, because this is not a luxury. This is a necessity for life, for maintaining life and economy in the region. And of course, cooling technologies should be diversified, or different types of different cooling technologies should be better investigated. Maybe apart from traditional vapor compression systems that we have, we can look into the, let's say, evaporative cooling or solar thermal air conditioners. There is a lot of room for improvement and for studies. And of course, another important resource that I would like to highlight is water, also a topic of our discussion today. Saudi Arabia has limited availability of natural water resources, but this is also important for surviving in the region. And this water at the moment for domestic use is coming from desalination, and desalination is energy intensive. Again, it is powered by fossil fuels at the moment, almost at 100%. And this is another challenge, a technological challenge for the future. How can we produce water in a sustainable way with a less reliance on fossil fuels? And technologies for water production also should be diversified. Probably they can be relied on solar as well. We have a research desalination center in KAUST that looks at the solar desalination. And yeah, there is a great room for improvement in this area.
Absolutely. I think what we constantly drive, I mean, for someone who's deeply interested in the sciences, not having them be deeply connected again back to the policymaking mechanism is almost, the worst way, especially when you're in a climate emergency and you're trying to solve for so many unknowns, and equally within our region, when you're trying to have very ambitious and bold targets that you're trying to meet. So back to that ambition, I don't know, Professor Rod, if you were able to tune into our call yesterday or our session yesterday. Essentially, there was a lot of question marks around, well, where will the water be provided for, all of these ambitious goals and targets of the Saudi Green Initiative, Greening Riyadh. Dr. Anna mentioned some of the potential implications of the types of trees that would be planted on, again, depending on the type of tree cover, of increasing air pollution versus decreasing it, which is the goal, stated goal and target of those goals in those initiatives, as well as potentially, some of the implications of holding a bigger wet bulb, let's say, and with it an increase in the heat index. So how would one manage or to navigate the types of crops and plants and methods with which you could have a greener Saudi, have a greener Middle East, but one that is not rife with all of these potential hidden gray areas or issues?
Well, I mean, that's a really serious question. I mean, how do we provide enough water for this Saudi Green Initiative? So I think one key is, again, to try to work with native species that are already adapted to these environments. They grow very slowly, but they use much less water. One of the one thing that the Center for Desert Agriculture is working on is called a project called Fast Fit Palms. So palms currently drink about 170 liters of water a day. And I think there's like, 30 million or more palms in the country. That's a lot of water. And quite a bit of that, I guess, is coming from, groundwater, well water, and now desal. So one thing that we're trying to do is trying to develop new varieties that, again, maybe drink, use half that water. And this is, again, by understanding genetic diversity and trying to combine the best properties of sustainability with the quality of the product being produced. So it's another factor is working with crops that can, or plants that can grow directly with salt, directly on salt, and that's a big project that we're working on, and I think it's complex, but that's why we're thinking of this paradigm shift. I mean, controlled environmental agriculture can recycle its water, and if you have a large enough scale, I think that the Saudis will be able to produce the majority of their high value crops. And using this sustainability is, again, recycling the water, because it could go 10 times as far. A liter could be used 10 times, for example, versus just it just goes much. It stretches the water resources tremendously. So we hope that we can really promote some ideas like that and get away from this carbon footprint of flying everything in. So there's a lot of questions to still be addressed. Thank you.
Really excited. I have a comment in the Zoom call. Essentially, it was addressed to Natalia. Every 1 degree has huge implications for health, and globally, 37% deaths are related to heat. He's essentially saying that KSA was missing in that study, but it's very important to highlight that kind of an aspect. And we have a question for you, Professor Hoteit. Could you please explain climate impact assessment, any plans for heat warning systems from health perspective? The study presented the thermal index and human thermal index based on which criteria? Vulnerability based on many factors.
So yes, there are plans. It's part of the center I just mentioned that will hopefully start very soon with the collaborating very soon with the National Center of Meteorology. There are plans to put warning systems for heats, for extreme heats at the seasonal, sub-seasonal scales, but also for droughts as well. So these are two components that will be developed as part of this center activity on top of the component of supporting the green initiative and see its impact on the regional, local, regional climate. Yes, the plans are there and they will be done. Now, what was the second part, please?
Yes. It was all the implications on human health. So it says that the study presented thermal index and human thermal index based on which criteria? So
we used a combination. There are several indices in there. We use 3 of them, and it's a combination of temperature, humidity. Humidity is a very important part of the. The Red Sea loses 2 meters of water per year in terms of evaporation, and it all goes to the atmosphere. So humidity is a very important part of this, and there's wind as well. So there are these 3 main components. Some of them include but all of them showing in the same direction. But again, what we see is that in the last 2 decades, the main regions that are concerning are the region of Taif, Medina, Mecca. The other cities are not that problematic.
That's true.
Okay.
Any final comments from any of our?
Can I have one comment, please?
Please.
So following our discussion on the Red Sea and its importance in the thermal regulation, in our findings, we observed that along the Red Sea coast, the impacts of climate change is different, and it varies from the north to the south of the Red Sea coast. And interesting observation was that the Neom, the area of Neom, the city of the future in Saudi Arabia, which is located near Gulf of Aqaba in the north, is experiencing one of the least warming trends. So basically, temperature extremes and temperature didn't change much historically there compared with other regions. What do you think? What is the role of Red Sea in this effect? Because for me, I cannot have, let's say,
Explanation.
yeah, honestly, I don't know much explanation since you're an expert, because people obviously ask why some regions are impacted more and some are less. Of course, Red Sea plays an important role, but maybe you can explain more.
For this, we see the same thing. We see in the north much less, but I would put that on the. It's more related to the global climate. What's going on? It's a different weather system that's coming from the north, and the southern area is a different weather system controlled more by the monsoon area, where in the north is coming from these disturbances that have been coming from all the way from Russia. So the Red Sea plays a role definitely in terms of humidity than in the large scale temperature, whether that's controlled more by the global climate. So there should be more changes happening south in terms of the large scale patterns than in the north. And this definitely I agree with the people. We need to understand the dynamics and what changed before, once we put these numbers. And I'm very interested in learning why it's mainly in the last 20 years, the area again of the mountainous area of Taif, Medina, and these areas that were most affected than the others. And we owe this study. Yes,
absolutely. I mean, we've distributed some posters of the beautiful graphics that Natalia was showing, and it's striking how red Mecca is.
Yeah.
And it's striking how, contrary to belief in terms of the precipitation, it has been not as bad as in other regions. So with it, these maybe more dangerous dynamics during Hajj and
exactly. We ought to understand this decadal variability was going on.
Absolutely. Well, thank you all very much for joining us from home. And I would like to thank our lovely participants for their brilliant insight and hopefully to better and great things. And we really look forward to see the results of all of these wonderful projects that you've started and see the great future that you hold in your hands, Natalia. Very promising. If this is an illustration of what PhD students look like in KAUST, then KAUST must be very proud. So thank you all for joining us.